Hi students, in this lecture I am going to discuss problems based on spherical mirrors. Let us see first one. An object and a concave mirror of focal length 10 centimeter both move along the principal axis of the mirror with a constant speeds. The object moves with a speed 15 centimeter per second towards the mirror with respect to a laboratory frame. Its meaning is ground frame. Okay. The distance between the object and the mirror at a given moment is denoting by u. When u equal to 30 centimeter, the speed of the mirror is such that the image is instantaneously at rest with respect to the laboratory frame and the object forms a real image. The magnitude of Vm is asked in 2022 advance. Let us see once the values given. Concave mirror, it's a focal length 10 centimeter, object speed 15 centimeter per second towards mirror. It is with respect to ground frame. Okay. So when distance equal to 30, distance 30, speed of the mirror is such that image is instantaneously at rest. So we have to find what is the magnitude of velocity of the mirror, right? See how to start. First note down the given data. It is now given an object. So this is mirror. Its focal length is 10 centimeter. At one instant, object is at a distance of 30 centimeter. Distance 30 centimeter. Its velocity is given, that is 15 centimeter per second towards mirror. Let us assume velocity of mirror is Vm. Let us take this as x-axis. So object velocity is along positive x-axis. Mirror velocity we have to calculate that we are not moving. Is it moving towards object or away from object? Let us assume it is along positive x-axis. Okay. Right. See, first of all, how to find velocity of image. We have learned that velocity of image with respect to mirror along x-axis is equal to minus f by f minus u whole square into velocity of object with respect to mirror along x-axis. This is what we have learned earlier, right? So here what we can write, minus, for concave mirror, f is negative. So I'm writing here with the sign convention, minus 10. Next, again minus 10, minus, you are given distance. Distance is now 30 centimeter. Then u coordinate will be minus. It is minus 30, right? Coordinate of object minus 30. That's why this is origin. Distance of object is 30. Therefore, coordinate is now minus 30. So minus 30 whole square. Velocity of object 15 minus velocity of mirror. We have assumed that velocity of mirror is along positive x-axis. Okay. Now see calculation for this. minus of plus 30. 30 minus 10, 20. Okay, minus 10 by 20 and a whole square. Minus is there. 1 by 4. 15 minus Vm. Okay. Now coming to here, this is velocity of image minus velocity of mirror. And condition given that velocity of image in ground frame is 0, right? So I'm taking it 0. Remaining is now minus Vm. Minus gets cancelled. 4 Vm. 4 Vm that is equal to 15 minus Vm. Okay. Now taking this one to here. 5 Vm equal to 15. That means velocity of mirror is now, it is 3 centimeter per second. Okay. So it is just write down the given condition. That is velocity of image is 0 that we have taken here. And this relation already we have learned in earlier lectures, right? And remaining just calculation part. Let us see next one. A person of a height 1.6 meter is walking away from a lamp post of height 4 meter along a straight path on the flat ground. The lamp post and the person are always perpendicular to the ground. If the speed of the person is 60 centimeter per second, the speed of the tip of the person's shadow, tip of the person's shadow on the ground with respect to the person. So asking 2023 advance. So we are given height of the person 1.6 meter and there is a lamp post. Height is a 4 meter. And given here speed of the person is 60 centimeter per second. We have to find speed of the tip of the person's shadow on the ground with respect to person. Okay. Let us see. First of all, see the given data. So person is walking. Let us take this is now lamppost. Its a height is 4 meter and there is a person walking and his height is given 1.6. Height of the man 1.6 meter and his velocity of man given 60 centimeter per second, right? Okay, now let us make diagram for shadow. When light falls on the person, right? Let us now consider this is now head of the person. Okay. So for this shadow will be at this point. Okay. We have to find velocity of that point, right? With respect to the person. Let us now consider this as A, this is B, C, D, and this is C. Okay. And let us take this A as X. where x is now changing because person is now walking, right? ED. And you can see here ED is known as length of the shadow. Students see carefully. When this lamp post is behind the person, from E to D, there will be no light. Okay. So ED is known as length of the shadow. Okay. And let us take this as Y. The length of ED as Y. Right. Next, what we have to focus on? We have to focus velocity of this point, right? This point. That means d by dt of x plus y. But he's asking that velocity with respect to velocity of the person. In this diagram, velocity of person is dx by dt. That is velocity of the man. So we have to find with respect to that. That means minus dx by dt. This is what we have to calculate. Okay. Now see, first of all, see any relation between x and y. So here we can take triangles. Triangle, it is ABD. Next triangle, triangle CED. From these two triangles, see what we can write. So we can write from these two triangles x plus y, x plus y upon 4 is equal to, it is equal to y by person's height is given as 1.6. It is 1.6. See carefully once. So we have taken triangles ABD and triangle CED. From these two, x plus y upon 4 is equal to y upon 1.6. Now let us simplify this. So here 4, 0.4 times. That means what we get here, x and y relation. 0.4x, that is equal to 0.4y minus y, right? That is 0.6y. That means relation between x and y. So y equal to 2 by 3x, right? Check it once. 0.4 times 0.4x plus 0.4y equal to y. So remain 0.6y. Okay. So we got y value 2 by 3x. Now see calculation of d by dt of x plus y. D by dt of x plus y. So in the place of y, I can write 2 by 3x. 2 by 3x. D by dt of 1 plus 2 by 3. How much? Into x. This is now 3 plus 2, 5. 5 by 3 dx by dt. Dx by dt value is now 16, right? It is now 20 times. This is now 100 centimeter per second, right? But we want to calculate d by dt of x plus y minus dx by dt. This is now 100 minus, this is now 16. So answer how much? It is a 40 centimeter per second, right? It is just matter of taking the diagram, and from the geometry, we can get the answer, right? Let's see next problem. An infinitely long rod lies along the axis of a concave mirror of focal length f. The near end of the rod is at a distance u that is greater than f from the mirror. Its image will have a length. So we have to find length of the image, right? Okay. See carefully how to solve it. So the given condition, this is now mirror. Suppose this is a focus. Okay. Now object is it is from here to up to infinity. Okay. This is up to infinity. Okay. So you are given distance equal to u, right? Then see what I can do here. Let us call this as point A. An infinite one is point. So we are placing the object along the principal axis. Okay. And if you observe for point A, image will be for A point A, image will be. See what we can do here. V coordinate is given by u into f by u minus f. So we are taking simply mirror equation 1 by f equal to 1 by v plus 1 by u. From this v value, u f by u minus f. Okay. If you take modulus of this, that gives us distance of the image of this point. What is that? Modulus of this gives us distance of image of this point A. Okay. Take it as VA. And coming to VB. This forms image at focus, right? Because B is now at infinity. Its image will be at F. Now we have to find the length of the image. Then we can write modulus of VA minus VB. Okay. See what is that? UF by U minus F minus F. So here I'm taking F outside. Remaining is now U minus F upon U minus F. U and U gets cancelled. Minus of minus of plus. It is F square by U minus F. That is now size of image. Okay. So this is our answer. Now see options. It is F square by U minus F. That means it is option D, right? Delhi. Okay.